In my first two DVDs, I did not have the space to include a lesson on stave construction or compound mitered stave construction. And I think every segmenter really should have a basic knowledge of this method of work. So I'm going to give you a quick lesson on how to calculate compound miters and how to assemble a simple vessel with compound mitered staves. So let's design just a basic open vessel which we'll build with compound mitered staves. This is just a relatively simple cone shape, nothing too specific. Now I've put the outline of my material, the width of my material here. This will give me an idea of what I can possibly build. Now the slope angle is from the horizontal to the side of this cone shape. In this case it's going to be 75 degrees, which I've just measured. To capture the return curve at the top, I need to be a little bigger than 6 inches, so I'll go 7 inches outside diameter. To calculate the width of the staves, the big end at the top, that's a simple matter of multiplying by pi and dividing. 22 inches is my circumference. Dividing that by 16 staves gives me a width of about 1 3/8 inches. Now I can go to a chart. This one happens to be in my book. Go to the column with 16 staves and go to the row opposite 75 degrees, and I'll get these two magical numbers. The blade angle, in this case 10.86, and the miter angle 87.05. The miter angle can be confusing. Depending on the saw you use, you may just need to measure over, say, 2.95 from the 90-degree marker. You can use these kind of charts for most any combination, a number of staves, and the slope angles from 0 all the way up to 90. It gives you everything you need on those two angles. Now to cut these staves, I've constructed a new sled. My old one was getting pretty beat up. It's got one end of this piece of hardwood secured by a screw, and I'm going to adjust it, the angle, to just under 3 degrees, pretty close to 3 degrees away from that 90. And then I'll lock the other end with a bolt to lock the miter in place. The blade angle I'm putting right about 11 degrees, maybe a smidgen under 11 degrees. A little bit of guesswork going on here. Now I'm going to do a test cut with MDF. The left side piece will become my stop block. If I tip both of these over upside down, they'll still perfectly match. I can put a pencil mark to indicate the width of my stave, line that pencil mark up with the kerf on my sled. It's a good idea to always put dust traps wherever you can. Here I'm just putting a little bevel so I get a good fit up against the stop block. Now I'll use this clamp to secure my stop block in place, and I've created a little hold down device, a stick of wood with a little piece of foam rubber under one end, held in place with a loose screw, and this wedge will cause down pressure on my cutoff piece. It'll secure it from bouncing around after it's free. It's a pretty simple matter to take the wedge out, remove my cutoff, flip my material, butt it back up against, and then put the wedge back in place to make a whole series of cuts. It's a cut, flip type of operation. By taping 8 of these staves together, I should create a half cone shape. I'm going to check these angles and see if I'm in the ballpark. Actually, they're looking pretty good. I got lucky. Most of the time it takes a few adjustments to get this close. If you're making several adjustments, only adjust the blade. Leave that miter angle alone. You'll drive yourself crazy trying to adjust both at the same time. Just work on that blade angle until you can put, in this case, 8 staves together into a perfect half cone. So I'm proceeding to cut my lacewood. One cut followed by a flip, lock it in place, make another cut until I can create or cut 16 of these staves. My sharp rip blade made some very nice cuts. I could probably glue directly from the saw blade surface. But just a kiss on this sander will improve things just a little bit more. So so I'm going to take the time to just kiss that sander. The gluing is, a step at a time. Pairs, using rubber bands in this case, and it doesn't hurt to throw a spring clamp on there. Whatever it takes. Here I'm touching up again because I've got a little bit of glue contamination on these surfaces. Now I'm putting pairs into groups of 4, which is actually 1/4 of the cone shape. Notice the way I stretch the rubber bands to the inside. That evens out the pressure. Now I've got 4 quarters ready to do a dry fit. I want to check these out. If I have to make any adjustments, I want to do it early. I don't want to wait until I have 2 halves and have to make a major adjustment. It looks pretty good. Watch the way I put this rubber band on. I'm really extremely stretching it to the inside, but by doing so, the stickiness of the rubber band allows me to put even pressure on this joint. So it does work, but you got to check it out ahead of time dry, get a feel for how those rubber bands go on. Now I do need to true up the 2 halves, but my disc sander's not quite big enough. So just some handwork with a piece of 80 grit paper that's been glued onto a piece of MDF. Spray adhesive works well for that. Just rubbing back and forth, I'll get perfect surfaces there. Dry fit, confirm that. This is a pretty easy glue job here actually, just a lot of rubber bands. Having a sled and miter angle and blade angle all set up perfectly is a valuable thing. I don't want that to go to waste, so I'm taking advantage of it. I'm cutting some more staves out of more material. This happens to be Liptus. Same kind of process. I've also cut 16 staves out of this curly maple. I'm testing the fit here with all 16. I'm going to do something kind of special with these. I really need a perfect fit. But before working with the maple, I'm going to glue my Liptus staves together with a piece of veneer between each stave. This will just give a little striped effect. The same kind of gluing process though. I'm just using a lot of rubber bands. The maple stave constructed vessel is going to be quite a bit different. I'm going to actually treat these individual staves as if they were a spindle. I've applied some double-sided tape here, so I can connect 2 staves to their inside surfaces, inside to inside. The clamp is just to give the tape a little bit more strength, just temporary. Now I'm going to true up this end and glue a little piece of scrap wood on the end here. Happens to be mesquite. Any wood would work. But I'm centering that on the end of these pairs of staves. Now I'm just going to do a little bit of touch up on the disc sander to make sure those surfaces are true to one another. Using a marking gauge, I'm determining the very center of the end of these 2 staves. I need that center so I can locate it on the tailstock of my lathe. Now using that center location with my tailstock and my chuck at the other end, I've mounted this on the lathe. I've nick the corners here just to confirm that I am perfectly centered. Now a little bit of turning. Use whatever tool you're comfortable with. I'm trying to get a shape that I like, just a curve on this pair of staves. Here I'm using a skew, which is kind of fun to do with so much air. I've got a shape that's not too bad. I've got minimal wood at the bottom, which is what I wanted. Now I can tear these apart and use one of these as a template by marking pencil lines on different sides of the other pairs. When this spins at a high rate of speed on the lathe, I can see that pencil line. It'll be just a matter of turning down to the pencil line, which will enable me to match those curves on all the other pairs. Using the bandsaw, I can get rid of that little tip that was added, pry these apart and get rid of the tape, clean up the tape residue a little bit. Then I can go to the chop saw and take off these big ends that I no longer need. Here I'm using a piece of double-sided tape on the top of a piece of board so that I can attach my staves one at a time and easily sand any tool marks off. This is just taking advantage of the ability to do this before I glue them together. I'm going to glue my staves in pairs, but before doing so I've cut these little pieces of veneer which will go in between. and I don't want to mess up that sanded surface, so I'm going to protect all the sanded surfaces with this blue tape. It'll just minimize the amount of cleanup I have to do later on. Here's 8 pairs, all protected with the tape with the veneers ready to be glued. As with the prior vessels, I'm putting these together 2 at a time, pairs with the veneer in between, using rubber bands, a lot of rubber bands, to secure these tightly together. So now I have 8 pairs all glued together. After they've cured, I'm going to take them apart, clean up any little bit of glue contamination that may exist, and do another dry fit of all 8 pairs. I really have to be very careful to keep this perfectly round. Do minor adjustments if I have to. Now I can glue together the 4 quarters. These 2 pairs make a quarter each. Notice again how I was stretching those rubber bands. Here's one more dry fit of the 4 quarters. Like I said, it's really important to keep checking this. I've decided I'm going to put the 4 quarters together in one step. I've got a faceplate mounted to the bottom of this piece of MDF, and I've drilled 4 holes which will allow me to secure a compression ring which will automatically center my 4 quarters and apply clamping pressure as I squeeze down on these screws. It's a pretty effective way to center mount and glue this together. A bunch of rubber bands finishes the job, and I'll put a hose clamp around the top end of this just to give that end a little bit more pressure. To mount my lacewood vessel, I'm using the large cone on my tailstock as a centering device. I've applied glue, and I'm clamping this to a piece of MDF. With my 3 compound mitered stave constructed cones, I have multiple options of what to do with them. Here's my plan. I'm going to take the lacewood one. I'm going to leave this one pretty much plain. It will be a vessel, a tall vase, with just the lacewood, no other embellishment. It will of course be finished, and it'll have the floating base on it. But this will be kind of the plain Jane of the bunch. And then I'll have my rib constructed vessel with these dark lines in between the ribs, and I'm going to put a thin dark rim on the top of this. That will be it for this one, but a completely different look, obviously. Now this one with the liptas and the walnut stripes, I'm going to put a top on this one. So I'll do the mortise and tenon fit. I'll put a thin rim, or I should say a thin layer of vertical grain walnut on top of this. But what do I put on top of that to close this up into some kind of a closed vessel form? Multiple options there. One option would be to take, say, a piece of burl wood, and I could cut a circle out of this burl wood, and I could put that on top of this and create some kind of closed form vessel with that on top. Here's the construction of the floating base on the lacewood piece. A dab of glue on the 2 ingrained ends of the disc. Some tight bond only on the ring that's going into the recess. I want to avoid any glue coming in contact with that disc. A little pressure. I've aligned the seams so they overlap here. Now I did the same kind of thing to all 3 vessels. Here I'm turning the tenon so this vessel can be mounted in a 4-jaw chuck. Here I'm taking off the MDF at the large end. Floating bases were installed in all 3 vessels, and all 3 vessels are now mounted on a waste block where I can proceed to turn. Here I'm working on the maple vessel. I need to put a contrasting dark layer on top of those staves. I've turned a half mortise in my vessel, and I've turned a half tenon on the Zericoti ring. Remember, this is vertical grain. Lots of glue. I'll spread the glue and then pull this apart. Make sure I've got glue on all the surfaces. Then I can use my tailstock as a temporary clamp. I also want to make sure I bricklay the seams. That's what this pencil mark here is doing for me. Now, building a ring with vertical grain is not much different than conventional rings. The wood is just oriented vertically. The cutting is the same, and then the gluing together of the segments is the same. It's actually a stronger ring because it's side grain to side grain. With a few dabs of hot melt glue, I can attach that ring to a disc of MDF with a hole in the center. Just screw it onto a screw chuck. That perfectly centers it. A little turning to true it up. Now I need to know the center of my wall thickness. Using my dial caliper, I've determined what that center line should be. And using the same tool, I've scored a line on my ring. Using a bowl gouge and then a diamond pointed scraper, I've created a tenon that'll fit into the top of my vessel. To fit these together requires some careful turning. Here you can see it's looking good, except I need to go just a little bit deeper. The glue job is pretty standard, just a little pressure from the ceiling. Now for that top piece of burl wood, I've just cut a circle out of burl wood and drilled a hole in the center so I can put it on a screw chuck. I'm truing up this surface here so I can put a couple layers of wood on top. At the top of the vessel, I'm going to have 2 layers of walnut and 1 thin layer of maple. Here I've got my walnut ring. I'm adding a maple ring to it. Then I'll true this up. Using a parting tool, I'll remove most of this maple. Who knows, I may be able to use this ring on some other project. Now after flattening this surface and hitting it with a little sanding disc, I'll part off the walnut, reverse this after I've flattened that piece of walnut so I can put this back together, which creates my 3-layer vessel top. Now next I can join this top assembly onto my burl wood. This is a pretty simple glue job. Reverse it around, hollow it out, and put a tenon on that lower edge which will fit into my walnut ring on the vessel. Now before I part this off, I've finished turned the inside of this and sanded it so it's ready to be glued on the top of my vessel. Now I prepared the top of the walnut ring here with a mortise. It's got a nice fit. I've used plenty of glue. I protected the inside with blue tape. For clamping pressure, I'm just going to stretch some duct tape. That works pretty well on this situation. I can remove the tape later, reach in there with a hook tool and clean up that inside seam. I can barely reach that seam with sandpaper. And then apply finish. Reverse mount these using a jam chuck. A little piece of foam rubber and a piece of wood holds things in place while I turn a finished bottom onto these. I've turned a little step on the bottom of all 3 vessels. This creates a shadow line between the vessel and the surface that it sits on. It just gives the vessel a little more lift. The last step would be to apply finish to the bases, but before that I put my signature, the date, and in some cases the wood species. Well, I hope I've got you interested in compound mitered staves. They're not that difficult and there's lots of things you can do with them. But a couple of things I just want to remind you. Make sure you keep everything going the same direction. Take the time, if you're going to put a rim on like this, to make the vertical grain so everything goes the same direction. Do the mortise and tenon fit. Don't forget floating bases. Don't just glue a piece of wood onto this end grain at the bottom. And if you're going to put a top on, burl wood is an ideal transitional material to go from this vertical grain back to this horizontal grain. Here's another tip. If you've got dark wood in the base of a vessel, and you want a nice place to sign, go ahead and inlay in a little donut-shaped piece of light wood. Doesn't take long to do, and it adds something to the vessel. A little surprise when people turn it over and look. Compound mitered staves can be used in a lot of different situations. The next lesson on ribbons shows one more use of compound mitered staves.